Today, on Into the Impossible, we have a truly out-of-this-world discussion lined up for you as we dive deep into one of humanity's most profound questions. Are we alone in the universe? Joining us to help us answer this age-old question is the brilliant Professor Adam Frank, a leading astrophysicist and astrobiologist from the University of Rochester.
How bad would the probability of getting life, of technological civilization on any planet across the universe, how bad would it have to be in order for us to be alone?
Adam's groundbreaking work on biosignatures, technosignatures, and the search for extraterrestrial life has radically transformed our understanding of the universe.
Because we have this tendency that if you build technology, your mind is going to be like our mind. And I don't think that's true at all.
In this episode, we'll explore mind-melting scientific frontiers in the quest to detect alien life and the potential of technologies like the James Webb Space Telescope. And lastly, the rigorous standards required to validate extraordinary claims about UFOs already being among us. Buckle up and get ready for an intergalactic journey into the impossible.
I want to welcome you back to the podcast, Professor Adam Frank. How are you doing for your second time on the podcast?
Doing well. It's a real pleasure to be back. I enjoyed last time. I'm sure I'm going to enjoy this time.
You finally, the book sales have finally sort of tapered off asymptotically from that first visit 3 years ago. I believe around now we talked about your previous book. Today we're going to talk about one of your books in detail, and we'll mention the other one as well. But before we begin, I do want to consult with Carl Sagan, our guru. And he said, that famously that extraordinary claims require extraordinary evidence. Adam, I'm a professional cosmologist for the last 30 plus years now. I've never reached into a drawer labeled extraordinary evidence. I think that saying's BS. I think it's it's cute. It sounds good. But really, scientists, we should have our mind on, being epistemologically, humble. And we shouldn't discard evidence or not. We should allow it to take us where the evidence leads us, rather. So what do you think about that flaw or that thought that it's a flaw in the great, otherwise great, perfect, saintly Carl Sagan?
Well, I think that it's funny you call it. That's why I call him Saint Carl also. And it's amazing how in the last two books, In the Light of the Stars, my last book, and then this book, he's just everywhere. Like his how many pies he had his fingers in, from climate change, the first studies of nuclear winter, to being in the just like he was in the office when James Lovelock came up with Gaia. Like he's not doing it. He's just sitting over there by himself. It's ridiculous. But I'm not going to be. I agree with that because we were talking about something in particular, and it was about UFOs, right? And in particular, what he was trying to talk to the UFO community about, which he tried very much to engage with them, was this tendency to see any evidence as evidence, right? So, and I covered this in the book, in the new book, in the little book of aliens, when I talked about Roswell, where like book after book after book gets written and there's more and more witnesses, but the witnesses are people like, somebody's uncle's cousin's hairdressers who knew a guy, who talked to a guy, who said he saw something. And it's like, oh, that's evidence that aliens landed on Earth. And so I think he was, within science, if you're a scientist, you understand what the standards of evidence are. When we talk about rigorous standards of evidence, you understand what they are. And in general, in any field of science, everybody gets held to those. But I think what he was addressing was this tendency within the UFO community to not really understand what standards of evidence meant and to take any fuzzy blob, any account by a guy, well, he's in the military, he must know what he's doing, he's an intelligence officer, he wouldn't lie, as being evidence of the most dramatic conclusion that there is. To me, the most important question in science, and it's been around for 2,500 years, is, are we alone? And so what he was pointing to there is you're not going to take a picture with a fuzzy blob in it, and some guy saying, I saw it moving in ways, no plane could move, as being conclusive evidence for that claim. And so I think what he was talking about, he was right to say you're going to need more than that, before I'm going to buy that we're being visited by technologically advanced species.
Yeah. And of course, in the zeitgeist nowadays, there's reports and there's, like you said, pilots. And I've talked to several of the prominent ones, including Ryan Graves, who, apparently won't talk to me anymore because he didn't get a joke that I made about his former, coworker in the Navy, is a friend of mine here who flew with him, who disputed. We did a podcast, all three of us in person here, but sorry, Ryan, if I offended you. But the point is, how much should we really trust eyewitness testimony? And these, it's always a question, because if you question them, oh, are you saying this? You don't have the balls to join the military and fly around in an F-18, Keating. I'm like, well, if I wasn't such, a fat ass when I was 18, maybe I would have, because but I am actually, I fly little Cessnas around, and I'm familiar with what happens. And we had a great, discussion about it. But the fact remains that all these people, David Grush is another one. Oh, how can you down him? And Lou Elizondo. And I just find that the grifter charlatan line has never been more clear. And as you point out in the Little Book of Aliens, to which we will now turn, there's good reason for the military to be investigating these things, if not only for the fact that it could prevent, the untimely accident occurring because they crash into a weather balloon or a retroreflector. So let's do now what I've patented since the last time you're on, and judge this book by its cover. So this book is called The Little Book. I listened to it on Audible, and I thoroughly enjoyed it. It's endorsed by past in-person guests, Kim Stanley Robinson, Carlo Rovelli, and many other people, Marcelo Gleiser, who you also co-wrote another book with. I should actually mention that book too. This is called The Blind Spot. And I loved Sandra Bullock in this movie portrayal of the blind spot. Now, we're not going to talk about the blind spot today, but we will talk about this. Adam, help us judge this book by its cover. Explain the title. There's no subtitle, and that's I think makes it a little book, but explain the title and the cover art, please.
I cannot tell you how much effort I put with other people into that cover. So the title, The Little Book of Aliens, came to me in the middle of the night. I was very happy with it because it kind of cracks me up, right? Because I had this idea of like, whoa, open to page 5 of The Little Book of Aliens now. So, but the idea was I wanted to give people like a really fast, fun, very sort of ground level view of what's happening in astrobiology now, including what was happening with UFOs. And so the cover, we thought so much about the cover, about how the cover could communicate something a little bit whimsical, but that also had the wonder, because that's the both sides. Like I wrote this, I'm from Jersey. The voice in my head is always kind of like, I grew up on Bugs Bunny, that kind of like sarcastic. And so I just wanted to write it the way what was going on in my head, which was going to be a little bit funny, a little bit sarcastic. But the reason I'm in this field is because it's so awesome, right? I mean, what I'm trying to communicate to people is so much has happened in astrobiology that we, in the next 10, 20 to 30 years, are going to actually have data that is going to address this question. I can't tell you what the answer is going to be, but for the first time in 2,500 years, we are going to be actually go beyond just arguing over your opinions, man, to actually having some data that we're going to be able to work with. And that awe was what I wanted to communicate with that title, with the cover of the book, whimsy and awe. And so I think, with that, the idea of just the arc of the crescent of the alien world with, the Earth in a kind of a cartoon way. We went through so much. I had friends of mine who are graphic artists. We really poured over that. So in the end, usually with a book, as they'll hand you they'll give you 2 designs to be like, well, choose between A or B or shut up. And this time my publisher and my editor, Sarah Huygen, was just so helpful. She was also amazing. And we spent a lot of time on it. So I've never been more happy with the cover of a book than this one.
That's wonderful. Yeah, I really enjoyed the audiobook version of it. The snarkiness of the frank trademark snarkiness comes through in the narrator. I really enjoyed it. And I guess the kind of first thing I want to turn to, I sent you a PDF that I made up, and this is a cosmologist take on the problem of what's called, one of these things that sounds dirty, but it's not. It's called panspermia. And that involves the transference of material, which may include biological material from planet to planet or from the cosmos to Earth and so forth. I believe maybe it was Hoyle who coined the term or popularized the term, and he was a character too. But the concept is that meteors hit the Earth and they hit Mars and they hit other planets and they blast off fragments. By the way, if you are blessed to be one of Adam's students, and you have or you have a .edu email address, you're guaranteed to win an actual chunk of space schmutz and real meteorite, which landed in Argentina some 7,000 years ago. And you go to briankeating.com/edu to win that. If you don't have an edu email address, go to briankeating.com/list, and you may win, you may not. But the fact is, Adam, that we exchange material all the time. And I asked this question to you, which I had actually asked of Joe Rogan talked to Joe Rogan about when I was on his Fair podcast, experiencing that. And I actually brought him, not only did I bring him a chunk of meteorite, Adam, I brought him a chunk of Mars.
Right.
So I have a tiny Martian meteorite, and I understand he smoked it, and I think he enjoyed it. But anyway, I said to him, Joe, because he's very bullish on aliens existing, the life existing in the universe, but he's not as sanguine about them visiting the Earth, even though he seems to portray it as a done deal in many ways. I said to him, Joe, imagine astronomers find a binary planet system, 2 planets in orbit around a sun-like star. They see on one of them lights, twinkling lights, eat at, Joe's, and they see all the signs of life, technology, everything, but they haven't had time to look at the other planet in the same orbit, more or less. What do you think the odds are? And I described it, and he said, "Oh, it's extremely high." And I said, "Okay, well, that kind of portends negatively for the ability and fecundity of life spreading throughout the universe, because we have just such a system, Earth and Mars, and Earth is teeming with podcasters and Kardashians, not Kardashians, but Kardashians." And the fact is, we have no evidence for now. It doesn't prove, as Carl would also say, absence of evidence is not evidence of absence. And you bring that up. So, what do you make of this statement? So, I go through the calculation in the email I sent to you, which you probably deleted. That's fine. That's fine.
No, I looked at it. I was just looking at it. It was what I love about you used the basic Bayesian techniques that are actually, people have used. So for people who don't know, the idea of using Bayesians the Bayesian formalism of probability and statistics, as opposed to the frequentist, is that when you only have rare events, when something only happens once or twice, or you only have data for it, how do you then extrapolate from that? So I find Bayesian the probability so important, and it's actually one of the foundations for my favorite interpretation of quantum mechanics, which is cubism, quantum Bayesianism. So I love the way you did that calculation. And of course, one of the things you ended up with about 8%, 8% probability that if you see life on one, would you see life on the other? Which actually, that's not that low. It means I have to look at 10, it's about 1 in 10. And so if I look at 10 binary systems, then I'm going to find one that has 2. And also, we look at Mars and we don't necessarily see existence of life on Mars, but it could have been earlier, right? That's really the thing. Mars underwent such extreme climate change that, if you looked at the solar system 3.5 billion years ago, you might have seen 2 green worlds. Also, there is a real possibility that Venus was a water world for a while, right? I mean, there's really evidence out there from the, I think it's the oxygen, is it the oxygen or the isotopes? I forget what it is, whether it's oxygen or hydrogen, deuterium isotopes, that Venus may have undergone a massive climate event about 700 million years ago. And before that, it could have been inhabited. So, we're getting a view of the solar system now, but it's possible it looked at different earlier. But again, right now, if you looked at Mars and didn't see anything and say yes, so 1 in 10 would fit basically with what we see, right? But it is, if it was 1 in a million, that would have been bad. But 1 in 10 means that, we have a reasonable shot of seeing maybe 2 worlds with. But of course, everything, as with always with Bayesian stuff, everything's in the prior, right? You had to come up with a probability that there's life on any world, which I think you used that argument based on extinctions to get, I think you started with 0.15 or was it 0.01?
Yeah. I think it's the 1.5.
Right. So 15%. Of planets that can have life will have life. And so that, of course, but everything in Bayesian probability comes down to what guess you're making for the prior. So if you'd chosen something much smaller than that, it would have been different. But I love the idea. It's very much in that spirit, like what David Kipping does. I don't know if you've ever had David Kipping on, but he's well worth.
No, he's scheduled to come on. Yeah.
Yeah. Mm-hmm. He and I, I've worked on a couple of at least one paper with him. And I love it. And where he, applies, he has great Bayesian kung fu. And he's used that to ask questions. Like our paper was, if you find a civilization, will it be probable that's going to be younger, older, or the same age? And the answer was much older. He's done it to sort of ask, what is the probability for, but using Earth's history, what is the probability for just planets having life versus planets having intelligent life? So I think that Bayesian framework is very useful.
Yeah, it's fun to do. It's just I'm an armchair alien hunter. You're a professional. Yeah, but I asked this, kind of a similar question to your fellow upstate New York alien hunter, Lisa Kaltenegger,
right,
when she was on recently, and the question of whether or not how do you, and she approaches things at a different perspective than you. I think she does follow more frequentist and also in looking for the chemical fingerprints in spectroscopy. But one thing that is just so interesting about the way that you approach things is that you guard against, kind of the rational exuberance, not irrational, but rational. This is, as you say, potentially, arguably, aside from cosmology and understanding the origin of the universe, which is way that the bread gets buttered in the Keating household, finding life in the universe would be a very close second. But the problem is we get so much nonsense. We get so much chaff that comes in. It's not really clear how to defeat this. I'm sure you get it every day as well. Professor Frank, I'm not good at math, but I have this incontrovertible evidence or belief that, Alcubierre warp drives or, and these are things people spend hours on, podcasts. It's just melting my ears. I've even got, professional trolls that pursue me and comment, how stupid I am because, I require actual scientific evidence. But the fact is, Adam, we have no evidence. And for life existing in the universe, we have an awful large, amount of space, as Carl said. And so it'd be a waste, but so what? Nature's not under an obligation to, make use of space as you see it. How many elements are there in the periodic table that have no, use as far as
nothing to do with life? Right.
But the argument, again, I'd love for you to approach this. I've asked it of many people as well. Like, I've been to Antarctica twice. I've been to the South Pole twice, and spent a good month or month and a half. Although it felt like much more. It felt like being in New Jersey. I'm a New Yorker too, so don't hammer me too much. But the fact is, it's 1/7 of the continents on the Earth's surface, right? And yet, there's no life there other than the life that we, scientists wearing red parkas, Canadian goose jackets bring there. And there's a couple of, giant sized seagulls called skua that are there. And then that's it. Sea lion, there's nothing. So if you said, well, space is the, available continent is the predictor of life, you'd be totally wrong. So why doesn't that apply to, the calculations that you do and others do with the calculation of how many possible worlds there could be?
Yeah. So, what happens always is that, and justifiably, people look at the number of stars in the galaxy and then the number of galaxies in the universe. And then it seems like, wow, there's so many stars. Of course the universe has to be teeming, particularly with civilizations. And that is possible. But once you start engaging with it, you start also coming to this radical possibility, looking at Earth's history of how many accidents that have happened were required for especially advanced life. When we say advanced, we have to be very careful. But, metazoans, animals, multicellular animals, that you start just getting a little bit humbled, right? That it's possible that, life requires, and especially anything more than microbes. In general, there is a kind of a consensus that microbes may be easy to get, which also, I want to say, if we only discovered other microbes, that would still be the most radical thing ever. I don't want to diss my dumb life, as microbes are important. And we can talk about how and why I think it doesn't matter, intelligent or not intelligent. I don't care. It's the most important scientific discovery in history.
Hey there, brilliant brainiacs, students of the impossible. It's your favorite professor, Brian Keating here. If you're fascinated by the search for extraterrestrial life and the mysteries of the universe, make sure you're subscribed and following the podcast on either video or audio formats. I've interviewed plenty of experts, skeptics, and believers in the quest to understand the question of whether or not we're alone in the cosmos. So until we finally have definitive answer to that question, make sure you're subscribed because you do not want to miss some of the interviews coming up on this channel. Now, back to the episode.
Although it's happened before, Adam. It did happen in 1996. In fact, it's featured in the movie Contact, Bill Clinton announcing the possible discovery. And to my knowledge, it wasn't officially retracted. Nobody believes that the Allen Hills meteorite contains fossil microbial evidence anymore in this professional community that you inhabit. Am I right?
Yeah, no, most people think that the evidence just wasn't compelling enough. There were enough counter arguments that this is not, you can't take this as being the kind of solid footing for microbial life on Mars. I still think, I did this paper with Woody Sullivan back in 2016 where we redid the Drake equation, but took out the question of whether there's any overlap. And we, with us and the civilizations right now. So we got the total, we were able to derive a probability. Really what we derived was a probability whether or not whether it had ever happened before in the entire history of the universe, whether or not how bad would the probability of getting light, of technological civilization on any planet across the universe, how bad would it have to be in order for us to be alone? It would be the only time it happened. And it ended up being a pretty ridiculously low number, 10 to the minus 20. Nature would have to be super biased against forming, going through the whole chain of events. But that's for the entire universe, right? The entire observable universe.
Over the history of the universe, too.
Over the entire history of the universe. Yeah, so on one level, I would argue that, if you really think that it's never, ever, ever happened before, then you've got to actually do the work to show why all the experiments that the nature has run, meaning all the habitable zone planets, why it's never happened again. But whether or not we're in a galaxy that is well populated, especially with technological civilizations, I think it's possible that the galaxy could be sterile right now, or that, civilizations don't last long enough for there to be a lot of overlap. We'll just see. I mean, that's the awesome thing. We're finally going to go look.
Part of my mission, when I've spoken to Nobel laureates, 19 so far, I've spoken to eminent scientists, colleagues, authors, fighter pilots, whatever. But whenever there's a teachable moment for my mostly, I won't say unfortunately, but it tends to be mostly male, about 85% male, but very highly educated students, graduate students, and postdocs, faculty, are my number one cohort on LinkedIn. But I always like to make these teachable moments. What Adam just did is an incredibly important moment for you, young person, and even older people. He's showing that he has the integrity. What you did, Adam, and I'm sorry to rephrase what you did, but what you said, but I think it's important to double click on it, so to speak. And that's that you have this incredible paper, and it comes out with really an optimistic, cosmically optimistic. But you're pointing out just now, you pointed out the inherent limitations of that calculation. It requires the age of the universe. It requires the entirety of the observable universe, which has a radius of 46 billion light years, not just 13.8 billion light years. It's 3 times as big because of the expansion of the universe. Anyway, students, pay heed to scientists like Adam. Emulate scientists like Adam, because my mission on this podcast is to kind of assemble this dream team of university professors that you can learn from in your pajamas and owe no tuition to, unlike my tuition, my college tuition I still owe to Trump University. But Adam, I wanted to kind of segue from that, because what I care about, I don't care that a protozoan existed in an M51, the Whirlpool galaxy. I have a picture of it over there, 4 billion years ago. I just don't care about that. But I care in the, let's call it, instead of the habitable zone of our sun, let's call it like the technological zone, the zone that would know about our existence from our technological broadcast in the form of radio waves and light and from cities and so forth. And I want to kind of ask you about this question, because I did a search. Again, I'm a cosmologist. The smallest things I think about are like, superclusters. Okay. But I had to demean myself and look up brown. Like, it turns out that there's about 15,000 stars within 100 light years of the Earth, meaning they could have heard the first, Jesse Owens winning the 1936 Olympics, right? So they know about us existing now. And so there's about 15,000, about half of those are brown dwarfs. So I don't know, maybe I'm sure my colleague Adam Burgasser and Jill Tarter, who coined the term, brown dwarfs, that they could figure out some way. But let's just say sun-like stars within a technological communications radius where we could have a communication or maybe even visit them. I mean, what does that probability rise to that we're the only one in that zone? Let's say it's pretty close to 1, right?
Well, okay. Well, first of all, I don't know if you want me to answer this now or we can put a pin in it, as they say. But I want to argue against that. You should care about a protozoan on in 51. Because so I don't know.
Let's do that. Yeah, because I was obnoxious. So yeah.
Here's the thing, right? Because you and I are both physicists, right? You know, we do astronomy, but we're physicists first. And the thing about life is freaky, right? As physical systems, there is nothing else in the physical world that we know of that's like life. Like black holes cannot hold a candle to how weird life is, right? Because if you gave me a star, right, at the beginning of its lifetime, and you give me its mass and its chemical composition, I could pretty much tell you everything that's going to happen in its life, right?
Yeah, they're fungible, yeah.
Right, main sequence, blah, blah, blah. If you give me a cell and then ask me, well, what's going to happen in a few billion years? I would never be able to predict a giant rabbit that's going to punch you in the face, right? Which is a kangaroo, right? Evolution, life is the only physical system which innovates, which creates, which, speaking technically, has you cannot pre-state the phase space of life. It literally opens up whole new windows of phase space of possible functions and forms. And in that way, life is the most interesting physical system that we know of. And so and right now, it is possible that there's only one us, that Earth life it's possible that Earth life was a stinking accident, right? And what would that mean? But if we find just one example of life, one other microbe, that's not from our evolutionary tree, comes from a different abiogenesis, a different event, that means there's lots more than one, right? From a Bayesian perspective, right? If I find two, now I can assume that, this happens all the time. And then all bets are off, right? Because life can create and it can invent, I am not able to say what kind of crazy things have happened. Choose your wildest science fiction, fantasy, and life could have done it. It could have, become so advanced that it literally restructures the universe because, it becomes the laws of physics. Because life has that possibility of innovation and creation. So that's why even one microbe, the discovery of it, would fundamentally change our understanding of ourselves, of life, our place in the universe, whether or not we're part of a cosmic community of life. So that's why I get microbes. I'm super pumped about microbes. Find me some.
I love them too. I mean, we're more microbe than man at this point. The only, again, to push back with love and respect, the only counterpoint I'd make is that, again, this evidence from 1996, when for a decade and a half or more, people didn't really disabuse. In other words, the retraction, the news comes on the front page of the New York Times. And I've had personal experience with this, with the bicep affair, right? So it occurs on page, the retraction, if and when it ever comes, is on B17 of the Sunday edition, which is the least read, Saturday edition, which is the least read of, right? So you write for newspapers, how important that the, placement is. It's on the front page versus, buried the topic of the retraction. We almost never have that. And I had on Guido M. Benz, who won the Nobel Prize in economics 2 or 3 years ago. And, he talks about this thing, the replication crisis, and which is a deep affliction. We have our own crises in cosmology, but they're of the scientific kind. Is the Hubble tension, is the Hubble constant correspond to a universe that's 12 billion years or 14 billion, right? So these are important things, but they're not crisis of confidence in the ethical practices. But I find in this field, I'm not going to say your field, because I see you as a physicist, not, coming to it, approaching it from like a Fermi. We wouldn't call him an astrobiologist, even though he thought about such things, right? Or even Drake, he was a radio astronomer, and that's how you got your start in some sense too. So anyway, the point is, there's a huge obligation when you have things like it goes on the front page of the New York Times. It's featured in a movie. People make policy. Dan Golden used that event to advocate for funding that. Hopefully you got some. I don't know, but the point is, don't we have these ethical obligations that we have to really tamp down? And I'm not speaking as someone who's never lived in a glass house. So to what extent do we have to be careful about because it's so important? About the importance of not only getting it right, but also doing the proper mea culpa when we get it wrong. In fact, as I advocate in my first book, we should have 10% of our PR budget should be reserved for retractions. So what do you think? How do we address, the replication crisis in astrobiology, where the impact might be much higher?
Yeah, no, I think that's an excellent point. I mean, and I love the idea of 10% for retractions. There was that famous, I remember the video I saw of it, of the guys who thought they discovered a planet orbiting a pulsar. And then they stand in front of, it's a AAS meeting, and they stand up, and this has been, again, front page news. Oh my God, first planet. It was 1990, I think. And they stand up and they give a 20-minute talk on how they were wrong, right? They go through all the details. It was periodic. It was actually a 6-month signal and everybody, they got a standing ovation from the astronomers, and I was like, yeah, this is why I love science. These people stood up and said, we were wrong. We're going to show you in detail exactly where we were wrong. And nobody threw eggs at them. They were like, thank you. We love you, So I think that's a great thing. The astrobiology community has done exactly this. Last year, 2 years ago, they had a workshop that Vicki Meadows from the University of Washington, she was one of the leaders, Eddie Schmiederman also was part of this, where they tried to say, like, look, how should we, what are our standards of evidence? What are the thresholds that we think have to be overcome before we say, like, yes, we've discovered a biosignature? And so I think that there's been a lot of work and a lot of effort to try and figure out, because the biosignature or technosignature thing, this is what's coming down the pike. Like, it could happen. JWST is, it's really on the hairy edge of what it can do. But the next telescopes that are coming up in the next 10, 20, 30 years, the Habitable Worlds Observatory, right? That's going to be optimized for that. So there absolutely could be a biosignature detection in the next few decades. And that could be oxygen. It could be, oxygen and methane. There's a whole variety of molecules, or these agnostic ones, which could be network kinds of thresholds that we could talk about. But either way, I mean, so I think the community has thought hard and will continue to think hard about how to properly tell people, this is what we found. This is what the confidence we have in it. Here are the possible false positives. Here's the limitations of it, because always our data is going to be a little bit crappy. So I think what you're focusing on is absolutely important, and hopefully will be followed.
So the book talks on the concept as life as we don't know it, unlike the Star Trek quote, right? Life. It's like life,
yeah,
but not like us, right? So what are some theoretical frameworks, the way you approach it, to expand on our understanding of potential other forms of extraterrestrial life?
Yeah, this is so thrilling, and I find it both interesting, both for the biosignatures, which is just the question of what other kinds of biochemistries might nature have put together. And then when it comes to technosignatures, how might intelligence or technological intelligence manifest itself with other evolutionary trajectories, right? Because we have this tendency that everybody's mind, if you build technology, your mind is going to be like our mind. And I don't think that's true at all. I think there could be a wide variety of cognitive structures. So when it comes to the biochemistries, what's interesting, people have done a lot of work on alternative, not using carbon, right? Because that's the first thing everybody always asks. It's like, well, what about non-carbon-based life? Well, silicon, you can, it's all about looking we got the periodic table. It tells you who likes to bond with whom, who does the chemical walk of shame. And so, you can see from that really there's good reason why we're made of carbon, because carbon is, carbon. Put that delicately, but carbon likes to bond. Carbon gets around. But so people are looking at, like, Sarah Seeger's done some really interesting work in what they called it the small molecule project. Life basically uses chemical Lego blocks. It takes little building blocks, builds bigger things out of this. This is where Sarah Walker's work is also very interesting on assembly theory. And so how might you find other ways of assembling things that does what life does? So there's been a bunch of work along that complexity, looking at like the complexity of molecules as a basis for how to scaffold the functions of life. And all of this requires something I'm very interested in. We have a new grant that we're studying, which is thinking about life in terms of its information architecture. And that is a way of doing it, thinking about life agnostically. Instead of like being like, oh, DNA and RNA and proteins, thinking about life just as a system which processes energy and information through networks of matter. is a way of really sort of releasing the constraint of our own evolution. And so I think these projects are just beginning and the search for agnostic biosignatures and technosignatures. And the cool thing about it is it requires us to not only imagine what we haven't imagined, we need to imagine what we can't imagine. And how do you do that?
When I look at these, kind of the attention that we get to, this topic, there's just no end to the fascination, and to live in this epoch where we have the JWST, which is, already returning incredible scientific results, including, measuring not just, exoplanets, but, exomoons and things orbiting around these exoplanets as well as their atmosphere. But talk about the technology. What to you is, the most important technology that we have? Is it Kepler? Is it JWST? And then what is coming down the pipe in a few years for our graduate students to get excited about?
Yeah. So the interesting thing about JWST is for both of our fields, right? For cosmology, the day it turned on, it was like, oh my God, we're seeing galaxies forming earlier than we thought they would. So I think for astrobiology, the most important thing, the real game changer, is this technology that is the basis for what we call atmospheric characterization, right? So people ask, how are we going to find signals? Unfortunately, we still have the ideas, the classic SETI ideas in our head about like, oh, there's, Jodie Foster listening on her headphones for, messages being directly at us. And that's how we're going to find aliens. And that's the old technology. We're still doing that. That's still super interesting. But because we know exactly where to look with our telescope, meaning all of these habitable zone exoplanets, and now we know how to look at them, which is we're going to be able to peer into their atmospheres. When a planet passes in front of its sun, some of the light from the sun passes through the planet's atmosphere and gets absorbed by chemical constituents in the atmosphere. And that means when that light finally gets to us, there's a fingerprint of exactly what's in the atmosphere. So we call that atmospheric characterization. So if we see something like oxygen, which can only be there because, as far as we know, for most planets, can only be there because life puts it in there, that's a biosignature. And having that technology, the technology to be able to discern those chemical fingerprints, those minute chemical fingerprints, that's the game changer for us. And that is how, so as I like to say, we're going to be like detectives. We're not listening for someone sending us a message. We're like detectives outside an apartment with our cold coffee and our crappy donuts, just watching. We're just watching, a planet go about its biospheric business or its technospheric business. And we can do that now. And we could not do that 10 years ago, 15 years ago.
And I've spoken to Sarah Seeger and many times in person and had her on the show. And back, we had her even on when there was the claim of discovery of phosphine. So if you had, the ear of God or Gaia or whoever you worship these days, Kathy Hochul, if you had a, kind of one chance, one molecule, what would that be? Would it be phosphane? Would it be sulfur methyl sulfide? Or
dimethyl sulfide.
Would it be carbon dioxide? Would it be oxygen? You only get one atom.
Only get one. You get one damn.
What would it be?
Chlorofluorocarbons. Because we published a paper. So I'm the principal investigator of the first grant that NASA has given in like 3 decades to really go after intelligent life, and particularly when it was really the first grant for atmospheric technosignatures. And one of the first things that we did was we did a study of how chlorofluorocarbons in a planet's atmosphere at the level of Earth right now, or at 5 times that level, 10 times that level, would JWST be able to detect that in the atmosphere of an alien exoplanet? And what we found was if the conditions if JWST turned out to have, proper kind of observing conditions, yes, we would be able to find the spectral signature of chlorofluorocarbons, even at our current Earth levels of that atmospheric pollutant. And chlorofluorocarbons would be a definitive technosignature. If you found that, you would know there was a civilization that either by accident or on purpose, because they're great greenhouse gases, and if you wanted to warm up a planet, you'd use chlorofluorocarbons. That would be a definitive signature of a technological civilization. So I'm all for chlorofluorocarbons.
Well, it would cause great horror from my late great colleague Mario Molina here at UCSD, who passed away sadly in October 2020. But he, of course, won the Nobel Prize for his work in discovering the threat of these
Yes.
things. To
Don't put any more.
now, imagine what's that?
I said, don't put any more in Earth's atmosphere.
Oh yeah.
But for
Right.
other atmospheres, yay on CFCs.
So speaking of that, we came together. It was a great kumbaya moment, and it was wonderful that this happened thanks to Mario's work and other scientists around the world. But often I hear about the threats of global warming, which you have novelly proposed as a really important technosignature, which would come from producing agriculture and on an industrial planetary wide scale. In fact, right. So that's one of your one of the highlights of your kind of the attention that you rightfully have gotten is for that as a technosignature, to use a term that Jill Tarter, past many time guest, has coined. I want to turn to that, and I've had on climate skeptics, Steve Koonin at NYU, and others, as well as climate people that are concerned, like Tim Palmer, who's also a Nobel laureate through the IPCC. Talk to me about reasons to be optimistic. In some sense, Charles Keeling and his son David, or David is the father, Charles is the son. Anyway, he made the case that there's only finite number of molecules of carbon trapped in the Earth's crust that are accessible. So there's an upper bound on how much carbon dioxide we can make. And it makes up, less than 0.03% of the Earth's atmosphere. But talk about planetary limits to growth. In other words, how could we get to a point, could we ever get to a point to make Dyson megastructures and really exploit those things? Or would we, extinguish ourselves, whether through war or climate change and so forth, on another planet? In other words, what is the great filter? In the words of past guest Elon Musk, how can we be expected to pass through it? And is there any hope from the fact that we live on a planet with finite resources?
Okay, well, let me address just the issue of the great filter, because the great filter is tied to the Fermi paradox. And here's my hot take. Okay, I'm going to say it right now. Good. There is no Fermi paradox. There is no Fermi paradox. Okay.
Love it. Go for it.
So let's be very clear about what most people think of as the Fermi paradox, right? So as we have talked about, Jason Wright and I in papers, there's the direct Fermi paradox, which is the one Fermi was actually talking about, which is why aren't they here right now walking around? Now, if you're a UFO guy, you think that's true. The rest of us know. But what most people think of when they think of the Fermi paradox is what we call the indirect Fermi paradox, or what's been called the Great Silence. And that's the idea that, oh, look, astronomers have been looking at the sky since Frank Drake. They haven't found a single signal. They've searched and searched and searched. And therefore, what's going on? There's no aliens out there. And that's where the idea of the great filter comes from. It must be that there's something which is keeping the universe from building technological civilizations. And there's a giant flaw in that argument right there at the beginning, which is that, oh, we've searched. The answer to the question is we've never searched. We've never searched for the most basic of reasons. There was no money to search, right? So SETI was always marginal at best. And then by the 1980s or so, politicians started making a lot of hay, beating up NASA anytime they tried to even drop a little bit of funding towards it. So Jason Wright did a great paper based on work from Jill Tarter started, and they added up all the SETI searches that have ever been done, right? And so the idea is, if the parameter space of the sky that you have to search to look for aliens was the ocean, and we're looking for fish in the ocean, how much of the ocean have we actually searched for fish? And the answer is a hot tub. That's how much water we've looked at. Out of the entire ocean, we've looked at a hot tub. Now, if you did that and you didn't find any fish in that hot tub of water you pulled up, would you be like, well, that's it. Ocean doesn't have any fish in it. So there is no Fermi paradox. There is no great silence. And therefore, there is no great filter. We don't know. We've never looked. And now, finally, we're looking. So let me I just wanted to bracket that, if that's okay.
Yeah.
Okay. Great. So now about our own future, though, and the future of aliens in general. Humanity, we've got some weird evolutionary heritage where we're like we're hive mind enough, we're eusocial is the word, that, we're very good at organizing ourselves and working together, but we're not, eusocial enough that we're not constantly at war killing each other. And, and so we've got this weird capacity from kind of our chimpanzee link as opposed to the bonobos. The bonobos will take care of conflict with sex. The chimpanzees beat the crap out of each other. That's obviously a simplification. So we may have things that no other civilization, no other species does. Other species may come across a nuclear power and be like, you built a weapon out of it? Like, what is wrong with you people? So in general, I'm quite hopeful that there's a variety of species out. There's a variety of cognitive structures, some of which will make long-term civilization, the sustainability of it difficult. And other civilizations will have no problem recognizing the dangers and moving through them.
Yeah, they'll be confused why we didn't use it to make pornography even more realistic, I think. What's wrong with you? So the concept of the rare earth hypothesis gets a lot of kind of attention, and I actually find it very appealing. I got some assistance in my first book from Don Brownlee, and that's that conditions for complex life to emerge might be truly rare in the universe. So you mentioned in the book the Miller-Urey experiment, and both Miller and Urey were at UCSD after the initial approach. But now you mentioned, as you describe in the book, it's not really suggestive that the conditions they replicated are actually representative of the conditions in the early Earth for a variety of reasons. They neglected eukaryotic life, making the great oxygenation and so forth. But just as I'm kind of skeptical about even microbial life, let me ask you to kind of strawman and maybe take down the rare earth hypothesis, so I don't get too confident in my assertion that even microbes may not exist. So what are some of the flaws in the rare earth hypothesis as you see it?
Well, first of all, I would like to say I like the rare. I think the rare earth hypothesis
Me too, yeah.
has a lot to it. There's some really strong arguments in there, which is why in general I tend to think there's probably lots of microbial. My bias, until proven otherwise, microbial life may be easy to make, and metazoans, complex life, may be difficult to make. I think the problem with their argument is they never, because they couldn't set any bounds. Like, how uncommon is uncommon, right? And the interesting thing, of course, what's really unique about if you can actually get to technology, right, is that when we have a recent paper on this as well, which I thought was really important. We were asking the question, what should you look for first, biosignatures or technosignatures, or which one are you more likely to find? Big difference between biosignatures and technosignatures, which is related to your question. If for biosignatures, they're tied to biospheres. Let's say you just have a microbial planet, right, and all microbial life dies. The biosignatures are gone. Technosignatures are tied to technospheres, but in a different way. Technosignatures leave, right? Right now, we have five spacecraft still beeping out very low intensity radio waves, but nonetheless, those are technosignatures. They've left the solar system, right? So once you start making technosignatures, they can spread across the entire galaxy, unlike biosignatures. So really, you only need, and this was the original Fermi paradox, and that was the insight that he had. Once you build a technological civilization that could be spacefaring, even if it's only within the planetary system, they can effectively be immortal and they can spread. And so that really changes everything. So even though I kind of agree I think it's going to be harder to get technological life than microbes. But once you get it, there's the possibility of having it spread and having it be very, very long-lived as well.
Hey there, it's me back again. As a professor, I have to assign you a homework assignment, and that's to join my Monday Magic mailing list. And you'll not only get extra credit for doing it, you may win a chunk of space dust, a real meteorite, that you'll get when you subscribe to my Monday Magic mailing list, where I share exclusive content, the latest alien discoveries, and highlights from behind the scenes of your favorite podcast. So if you haven't already subscribed, head over to briankeating.com/list and join. You'll be entered to win one of these beauties, a real 4.3 billion year old piece of space schmutz. And you're guaranteed to win if you have a .edu email address and you live in the United States. Go to briankeating.com/edu to enter there. Now, back to our alien overlords.
Talk to me about the, kind of video evidence, the eyewitness evidence that you describe early in the book. The go fast, the gimbal videos, the claims by David Fravor and his wing woman, Alex Dietrich, who I've talked to, at least by phone, not on the podcast. Talk about those claims and to what extent should we, be requiring and demanding that the data's ours, and we own the data as citizens of the U.S. and taxpayers, presumably. Talk about those videos. Are they convincing, or how do you, as a professional, astrophysicist, how do you interpret them?
Well, the first thing is so I've spoken with Ryan Graves a bunch of times. And I really actually liked Ryan's perspective.
Oh,
He's like,
I had him over for Shabbat dinner.
Yeah. Yeah. And his perspective, he's like, look, I'm just telling you what I saw. It's your guys' job to go figure it out. I like that. He wasn't like, he's not saying it's aliens. It's like, it's just this is what I saw. I want you to know. And also from that, I think it's fine. There should be no stigma for the pilots to be able to say, look, man, this is what I saw, and do with it as you will. The question is, and this is where people take what Ryan Graves and others say and spin it into this thing of that we're being visited by a highly technological civilization that wants to hide, yada, yada, yada. That's where the problem goes. And those videos, right? Those videos, people need to understand, those videos in no way can be treated as scientific evidence of anything. Why? One, they're pre-digested. Somebody cut them up and you released, and there's only 3 that get replayed over and over again. It's not like there's 10,000 of them. There's the same 3, which we see over and over again. We don't get any.
From 25 years ago, too. I mean, these are not recent videos.
Right. Yeah. And even like we hear this pilot chatter with like, oh my God, this is happening. Now, I'm not doubting that that's them, but how do I know that's them? Because I didn't get the raw data. And I also don't know the cameras. Look, when JWST, if we were to say that we found oxygen, a biosignature, we know what the JWST, how it responds to, infrared, near infrared, far infrared, at this temperature, that temperature. The instrument is fully characterized, right? We don't even know when was the last time these cameras were serviced. How do I know there's not a glitch in them? How do I know there's not a
glitch? In fact, some of them, Ryan was operating a brand newly installed radar system in his F-18.
Right. How did, and so unless you can't make a claim like we've discovered evidence of alien civilizations based on, any kind of evidence where I don't have this thing that took the data. So that's what's most important. And then, of course, people like Mick West have shown that, look, the cameras rotate, have given lots of plausible arguments for why some of the behavior seen in the videos is not that extraordinary. There was, I forgot the astronomer's name, who was part of the NASA's panel, where it looked at the data on the camera and calculated that in one of the videos, it was moving at 40 kilometers an hour. I could do faster than that on my mountain bike, right? So it's just like, and everybody pushes back. But I just think like those videos, we've got 3, they're pre-digested. They've been used over and over again. When you examine them, a lot of times kind of the claims of them being extraordinary fall apart. The various government agencies which have been tasked with looking at all of these, the UFO sightings or UAP sightings, they come to the conclusion that everybody else who's ever looked at it, 96, 97, 98% of these are explainable, right? And then there's a few that can't be explained. And some of those because you just don't have data to, even start an investigation. And then a few of them, as I say in the book, are freaky deaky. And I'm all for having a agnostic, open, transparent, scientific investigation of the rest of them, because that would be a great in a world of science denial where people are saying climate change isn't happening, even though like the evidence is like literally on your front page when, San Francisco skies are red in the middle of the day. That never happened before. In an age of science style, it would be great to have this as an example so people could see how science understands what it understands. But there just is zero data from any of these things that is compelling enough to drive us to the conclusion that we're being visited by alien civilizations with high technology.
Yeah, and it sounds like you really haven't updated your perspective, which I think is understandable since your 2021 New York Times piece that I'm a physicist who searches for aliens, UFOs don't impress me. And the thing that I kind of resonate the most with you is that it's the most pernicious outcome of this and problem with this is that it detracts from the scientific process that is going on to do it. And then scientists like you will be accused. I'm sure you're just in NASA's pocket and you're just paid by NASA. Like Upton Sinclair said, you can't get a man to understand something that his job requires him not to understand. I mean, I'm just from big cosmology that is invested in lambda CDM. And,
big cosmology.
Yeah, I get that all the time. And so I've had on, people, I'm actually interviewing is Rajendra Gupta, who believes that the universe is 26 billion years old. But you say the most frustrating thing is that it obscures the fact that scientists like me and my colleagues are on the threshold of gathering data that may be relevant to it. And Adam, isn't it true that you and I would be, among the most, perhaps you more even than me, excited if these are real? And that's another thing for my young students to think about. I mean, Adam has the perspective not to claim, as many have, that, not only are they definitely here, but we can interact with them, because that would be the most exciting discovery and probably be an incredible breakthrough, not just for you personally, but for humankind. So I think guarding yourself against this confirmation bias and this kind of optimism bias is incredibly important. So students take note of that. Also take note, you can get your own meteorite if you go to briankeating.com/list. Adam, we've got a bunch of questions from the audience. I know you only have 12 minutes left, so let's make it quick. You can always ask questions at briankeating.com or my Twitter. Follow Adam Frank 4. And here we go. So first one I want to ask is from a University of Rochester grad. Bachelor of Chemistry. When is the U of R laser lab going to have its commercial breakthrough in laser fusion? I worked there as an undergrad 40 years ago. The federal government is putting $1 billion into that, you rich Rochesterians. A horrible investment for you. When is that going to be fired up and using to blast alien civilizations out of existence?
I know. It's a giant laser. It is cool. That's one of the coolest things about working at the University of Rochester is the giant laser. It's the second largest laser in the world.
Do any of my fellow Jews control that? Do we have any control over that laser?
So the cool thing is that, we had this breakthrough a couple of years ago where we actually finally, not NIF, wasn't Omega, the Rochester laser, but we finally achieved break even. Like we've shown that, yes, humanity can trigger sustainable fusion. So, but the commercial application, I mean, it's a long distance from doing it, under, once, and then being able to get it like every 10th of a second. So I think we're still decades away from that. I mean, which is funny because fusion, that's the joke. Fusion is always decades away. But at least, it used to be that just getting fusion at all was decades away. We passed that. So now we're decades away from actually having a commercial plant. But maybe it'll be sooner from some other mechanism. Because once you show it's possible, then lots of things can happen.
So thank you, JMF 5246. I was going to use that as a name of one of my kids, but I didn't. Next question comes from Russ Chadwell. How old was the universe when all the building blocks for life were finally available?
That is a great question, right? And it's, what you need is the, stars, and the one generation after another of stars building things like carbon and nitrogen and phosphorus and sulfur and things. I think it's reasonably early. Like, I don't know the exact time, but certainly, probably within the first couple of billion years, I'm going to guess, and people can correct me if I'm wrong. But that you had enough generations of supernova, because it's really mostly supernova that are building the more, advanced ones, or larger, molecules, chemicals, elements. So I think it's, relatively quickly, within a couple of billion years, if not sooner, you've got what you need to start building biochemistries.
And next question comes from Kaduramudu43. If there is intelligent, technologically advanced life like humans elsewhere in the galaxy, would they have bodies like us? They would need to manipulate objects to build things, communicate with complex ideas. Would this not mean that convergent evolution made humanoid bodies?
This is a great question. Thank you. It's a really excellent question and detailed. And my answer is, my feeling, I have a whole chapter on this, is no, you're never going to see humanoids again. You'll see jointed sticks and you'll probably see, curved surfaces to fly. But the idea that you're going to get the exact, trillion different accidents that lead to like a head sitting on a shoulder with, I don't think that's ever going to happen again. Because, convergence doesn't mean convergence to a particular form. It means convergence to function. And there's lots of ways to have the functions that an arm does. So yeah, this is, of course, it's a guess, but my guess is that no, we are the only humanoids in the universe.
Joe Space Boss asks a very long question, but it boils down perhaps to the last sentence, which I might embellish. When it comes to funding, isn't there jealousy that only government and military scientists get access to it, and the ones that work at universities like you and others don't get this? So I want you to answer that question. Are you jealous of those rich flyboys and girls in their Zoom jets? And do you really think you'd get access to it if there was, say, a cover-up or some conspiracy to preclude the whole world from panicking over the existence of alien technology?
Well, first of all, in terms of jealousy, yes, I'm jealous because I want to fly jets, sir, very much. And when I talked with Ryan Graves, it was like he wanted to talk about it. I was like, look, man, tell me what it's like to land one of those things. He's like, can we get to the other? It's like, no, tell me again about landing. So, no, I'm not jealous because I don't really think that there's, this idea that there's been a 70-year cover-up. I just thought, the government is not very good at keeping secrets, right? If you look at it, because there's not one government. There's lots of different government agencies who hate each other, and so I just don't really think that and this idea, that the government has known and is not saying, it goes all the way back to like literally 1952. You see it again and again. The government knows, they're not saying, nobody can ever find anything. I just don't take it that seriously. I don't see and it goes nowhere. It's a black hole where you can go into and you're never coming out of, so I don't think about it very much because I don't really see it leading anywhere. And I don't really have any confidence that it's actually, that there is anything there. But go ahead, have government. Look, I'm all for open transparency. Let's have hearings. Let's find out what the government knows. But, on a probability scale, I got other things to work on, which I think is going to pay off more.
And then maybe, the last question, sociological question. What do we make of these, kind of beefs, between Avi Loeb, Jason Wright, Steve Desch, and many other people in the techno signatures world, and then other people in the life and panspermia world that argue about assembly theory versus directed evolution or even intelligent design. What do you make of these controversies? First of all, can't we all just get along? What is going on with Avi and Jason Wright and your community seems to have a lot. I don't want to point the finger at you at all, but you're the biggest, most munificent gentleman in all of astrobiology, as far as I can.
Oh, thank you.
But anyway, Adam, what's going on? Why do these people hate each other so much?
Well, I don't think they, listen, Avi Loeb plays a very singular role. In the rest of the field, I don't really see the field being any more than anybody else. In cosmology, man, there's some beats, right? I think the problem for astrobiology is that it gets so much attention. And, Professor Loeb has, gone off on his own in ways that I think most of us, almost everybody else in the community has a hard time with. So I think Avi's pretty singular in what he's done. And I have great respect for the work that Avi had done in technosignatures. He was a leader in the field. I have questions about the claims he makes now. But so I don't really see it as being, I think it's because it's such a high profile field, and because of the claims Avi himself has made have launched to the stratosphere of media attention. But the rest of the field I see is quite benign, and I like working on it every day. Other than Professor Loeb, it's got the usual amount of scientific, because listen, in science we love ripping each other apart. That's our job, is to rip each other apart ideal-wise. But in terms of cordiality, everybody's pretty damn cordial. That's my, I'm going to the Astrobiology conference next week, and I don't anticipate any, other than the usual fights, I don't anticipate anybody being.
What do you make about these, astrobiology so white and these policy papers, and it sounds like struggle sessions that come on from an outsider? What do you make of the kind of cultural implications and maybe ethical against marginalized communities? What's going on there in that community?
Well, there's a real point there. I mean, listen, like I said, everybody should get along, everybody should be reasonable, everybody should be. But the thing, what's really interesting about SETI is that, or in general, here. The interesting, unlike cosmology, really, where you don't really have to think about cultural influences in cosmology, or maybe they're downstream, but thinking about if you're doing technosignatures, I don't think you have to worry about this for biosignatures, but technosignatures, you've got to ask, what do you mean by civilization? What do you mean by intelligence? What do you mean by, and that requires you to actually talk to a broader community of like anthropologists, archaeologists, sociologists. What do we even mean by technology? And so I think the field has opened itself up, rightly so, to get past some of the limitations that we have. So let me give you an example, right? Here's this one that really cracks me up. There was the famous Bakunin meeting that Sagan held, I think it was 1972. And they invited lots of physicists and they invited one historian, right? And so, the one physicist after another is getting up and saying, alien civilizations will progress this way, and then they'll do this, and then they'll do that. And the historian's like, what are you guys talking about? Like, where did you get these ideas from? He's like, no human civilization ever has done that. And you know what they did? They're like, shut up. Like, we don't want to hear from you. And so he wrote a really funny piece later on about this. And so it falls really when you're talking about technology or techno-signatures, you got to broaden your views. And you got to broaden your views more than the culture, the European culture you came from. Because, if you're going to ask about how different might a alien civilization be from human civilization, then you better at least consider all the ways human beings have made civilization. And it's more than just, Paris. So I think some of that has gotten some of the media stuff has gotten played in ways I thought that were ridiculous. Sometimes it can stray off in ways that I don't necessarily agree with. But overall, the idea that you got to go past the biases that you have, I think is just critical.
Question goes to the host, Matt, is how are you changing your pedagogical techniques, tools, and the age of AI, other things you and Marcelo and others have talked about? How, I always joke our profession hasn't really changed in 1,000 years since the very first university opened in Bologna, Italy, in the Western Hemisphere in 1080. And, they had this barbaric practice where they didn't have tenure. So, Adam, how is our profession changing as you see it? And what can we do to avail ourselves of new technologies and methodologies of communicating to our students?
This is a really interesting question because I think about this a lot. Because I got to tell you, I don't know if you see this, I see a really profound change in the students over the last just 4 years in detrimental way because of the technologies, right? So I do not allow cell phones or computers in my class because, I try and tell students, I can see everything you're doing. So when they're like this or, and I'm like, look, you're clearly not paying attention. And I have as much problem with, electronic devices as anybody else. I actually think in a certain way, we do have to avail ourselves of the new technologies and see the way, like, for example, if we're teaching fluid dynamics to students, it's like, look, man, yeah, you got to solve the analytic equations, but go write your own piece of code, to simulate these things. So I think in that way, physics education has really blossomed because now people can actually play with the equations rather than just, solve the really hard integral, though that's still important. But when it comes to like introductory kind of stuff, non-science major stuff, I actually think there's a certain way in which we have to conserve. We have to conserve the part of scholarship and teach this to students about focus. The worst thing these technologies do to us is they split us. We're never anywhere, right? We're never actually here. And what scholarship requires is deep thinking. You got to like actually hang on to something for a few days, even one idea that you're just slowly trying to pick apart. And maybe we need to like actually hold the walls up and be like, look, these technologies are great. You got to use them, but you got to have discipline. And what's real is not what's on the screen. What's real is your experience. And you got to understand that these technologies, some of how they're being deployed is all about making the money. You are the product, right? And so you should be really careful of that to reclaim your own damn life because, these technologies, somebody's making chingo off of it and it's not you. So, I want students to really be aware that this experiment got run on them. And I don't think it's worked out well for any of us. It might
be those big, those cosmologists that work for big cosmology.
It's you guys in
big lambda CDM Adam. It's a reality. Adam Frank is a professor at the University of Rochester's scientific research has impacted their search for star formation, evolution of stars, and in particular studying the life and existence of life in the universe. He's a co-founder of the 13.7 Cosmos and Culture blog that originated, and you better change that if the Hubble tension gets resolved, on NPR. And he's a regular contributor to New York Times, All Things Considered, and many other venues. Adam, thank you so much. You're the one of the most frequently requested guests, and my audience loves you. Hopefully you'll write another book with, maybe we'll get you on, and maybe you and Marcelo will come back together. Other co-author. Thank you so much. Have a great day. Sorry I kept you over a little bit.
No, it's great, Brian. I love talking with you. It's so much fun.
We'll have some roast beef on WEC.
That'd be good.
If you watched all the way to the end, I know you'll love this interview with Professor Sarah Walker, a theoretical astrophysicist who studies alien life as well. And click here for a playlist of the best extraterrestrial episodes on this channel. See you next week on Into the Impossible.